All right, so we left off last time with conditionals, and then we gave a really brief introduction to loops, which is where I want to pick it up from last time. So Java has both for loops and while loops, and these are structured exactly the same as in the C programming language. Slightly different from Python, because Python really only has for each loops where you are iterating over an element in a collection or a sequence. So for example, if you wanted an idiomatic for loop, like for I running from 0, 1, 2, 3, 4 up to some number, then you would use that range function, right? It's a little bit different in Java because you have a traditional for loop, a traditional idiomatic for loop. For int I equals 0, I is less than, say, n, I plus plus, where n is some variable, right? So let's just go ahead and set n here to be 10. And then within that loop, again, you have opening and closing curly brackets for all code blocks in Java, just like in C. In Python, you only have the colon, and then you rely on indentation and white space to denote your code blocks. But with Java, it's going to be opening and closing curly brackets. You still use indentation, and you still are consistent about your indentation with respect to style, but otherwise, white space doesn't matter. You could screw up the white space as much as you want, right? Take out all white space entirely in this entire file, or tab over, or space over, or something like that. And syntactically, it'll be exactly the same thing. It'll compile to exactly the same thing. But if you were to do this in Python, it wouldn't even run. It would give you some sort of an indentation error. Remember, we are online, so if you have any questions, you can go ahead and post to the YouTube live stream here. Remember to fix this. You saw this in Lab 1. You can always go ahead and reformat it. For Mac users, that's going to be Shift-Command-F, right? And it will automatically reformat everything for you. For Windows users, I believe, don't quote me on it though, I think it's probably Shift-Control-F or something like that. All right? So let's go ahead and print out these values, system.out.println, right? I. Well, what's it going to print? An idiomatic for loop here starts at an initialization. So I is going to start at 0. While I is less than n, right? So that's your continuation condition. As long as the value of I is strictly less than 10 here, it will continue. This entire loop will be executed. And what will it do? It'll simply just print out I. And then on each increment, at the end of each loop, it'll increment I by 1. This plus plus might be new to the Python folks because Python does not support this. Instead, Python, you would do something like this. I is equal to I plus 1. Or you could shorthand this in Python using plus equals 1. Either one of those has the same meaning as plus plus. It simply just takes the value I and adds 1 to it. So it goes from 0, 1, 2, 3, 4. What is the last thing that's going to be printed here before I actually run it? What's the last value? 9. Why doesn't it print 10? N is 10 here, right? But I define this as strictly less than n, right? Strictly less than 10. 9 is strictly less than 10, so it'll get printed. But when you hit 10, it is no longer strictly less than n, and you jump out of the for loop. So let's go ahead and save this and run it. There we go. 0 through 9. Now, what if you do something much, much larger? I don't know. There. 1 million. That's 1 million there. All right. So what's this going to print? 0, 1, 2, 3, dot, 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 all the way up to 999,999. Right? Well, what if something went wrong with our program? For example, I would say I don't know, double foo is equal to 1 divided by I minus 500,000. There we go. So predict, what's going to happen with this for loop here? It's going to chug along, right? I'm not doing anything with the value, or I'm just trying to cause an error here. It's going to chug along until I hits, what 500,000? What's going to happen when I is 500,000? 1 over 0. Can you divide by 0? Nope. Let's find out what happens. Right? Something occurred. Right? Now, it's obvious what happened. I divided by 0 on that line when I was equal to 500,000. What if this was a bug, though, it wasn't that easy to trigger, and it wasn't that easy to determine what was going on. That's where a debugger comes in. And this is why I waited up until, traditionally in a computer science 1 course, you wait until after loops to introduce a debugger. Why? Because you need a substantial amount of code and code background to even get to the point where you have something that's worth debugging. So at this point, let's go ahead and introduce the debugger, right? I know that something is happening on what line here. I'm reading demo.java line 10. So what I'm going to do is I'm going to come over to line, say, 9 right before it, and I'm going to set what's called a breakpoint. All I did was double-click this column over here, and it causes it to have a little blue dot there. That's going to be a breakpoint. And I'm going to be able to run the program up until that point, at which point it'll pause the execution, and I'll be able to take a look and see what's going on in my program. For those with a C background, this is exactly like GDB. For those with a Python background, if you used PyCharm or some IDE, I'm sure that you had some sort of a debugger. Otherwise, what debugger did you use? Anything? Anything? All right, so you probably did what we call poor man's debugging. You have a bunch of print statements, and you print a bunch of stuff out until you get to that point. You can afford something better now, right? That's poor man's debugger. We are now rich people, right? Because we've got a full IDE and a full debugger. Let me come over to up to this little icon. You might have to squint your eyes to see what it is, but it's a little bug, right? And we're going to debug this thing. I'm going to switch to my debugging perspective here, right? And this gives me a lot of information. First of all, it gives me the full stack trace over here. It also allows me to view variables over here. Variables such as the arguments that were provided. Hey, there's the command line arguments that we provided last time. Now, right now, the program is paused. You can see that because I could stop the program, I could continue the program, I could stop it, or I could step line by line through my program using this step over feature. All right, so let's go ahead and go with the first iteration here. Nice. It printed out 0. That was the first iteration. Step, 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 right? It printed out the second one. I'm able to step through my program line by line, and I can come over here and view each one of these variables. There's n, it's 1 million. There's I, it's currently 1. And anytime it changes, let me go ahead and unfocus it. Anytime it changes, you'll see here that it's going to be highlighted in yellow, I believe. Yep. Oh, okay, well, let me click something else there. It was highlighted in yellow, right? And that tells me that it changed. There's a big yellow sign here that it went from 1 to 2. Wow, cool, right? All right, I can go ahead and continue stepping over, stepping over, stepping over, or I can go ahead and resume the program. But remember, I've got that breakpoint there. All right, all it's going to do is go resume the program until it gets to the next breakpoint. This is useful if you've got a program that's 1,000 lines of code. No function should be that big, by the way, but let's suppose that there is. You've got 1,000 lines of code. You will go ahead and set a breakpoint on line 100 because you don't want to go through those 100 lines of code to get to that point to look and see what's going on. So you fast forward through the program until you get to that point. Okay, everything looks good now. I know that the next 300 lines of code are good. So I'll set my next breakpoint 300 lines down. You can set and unset breakpoints throughout the debugging or prior to debugging. To unset, all you need to do is double click it again. Right? But remember, something was going on, something was going wrong here when it hit 500,000, right? If I just go ahead and click through this, okay, well, I'm going to be clicking here for a long time. It takes 3 clicks for each iteration, and there's 500,000 iterations to get to the point where it actually occurs. And so I've got about 1.5 million clicks in front of me. Sound like fun? No. So in GDB, what would we do? We would set a conditional breakpoint. So let me come over here, and you can view all the variables, but you can also view all the breakpoints that you've set. Here's that breakpoint that I set on line 9. I'm going to change it to be a conditional breakpoint. Only stop the execution of my program when I ends up being, and unfortunately I can't zoom in on this, but I is equal to 500,000. Or maybe I want to stop one iteration before, and so when I get to 499,999, right? Did I do enough nines? Yes. No, I did not. All right, there we go. 499,999, right? There we go. Now it's a conditional breakpoint. Now I'm just going to go ahead and resume my program. It's going to immediately skip over those 500,000 iterations that I know that are fine, right? See the execution? It continues. Now it's significantly slower because I'm running it through the debugger. The debugger is necessarily monitoring my program. All right, this is too slow. I'm going to go ahead and kill this, change this to, say, I don't know, 5,000, or let's go with 10,000. There we go. And I'll come over here and change my breakpoint to 4,999. There we go. All right, and let's go ahead and run the debugger again. Yes, save it. And when it gets to 4,998, right, you can see that the variable is now hit 4,999. And now I should have changed this too, but you'll see that if I had changed this to, what should it be? 5,000, 1, 2, 3, save this. I'm going to have to restart it. When the breakpoint gets to 4,999, I can now slowly step through line by line. Okay, I know that something is about to occur on this line, or on the next iteration. All right, so that's fine. That's fine. It prints out 5,000. And now when I get to the next line, I can start taking a look at stuff. Well, I is 5,000. We subtract 5,000, so that'll be 0. And then I have 1 divided by 0. Oh, okay. Obviously, I can't do that. Right? Conditional breakpoints. Super powerful stuff. You can go ahead and resume. You can pause execution, so if you get stuck in an infinite loop, for example, while, I'm going to go ahead and get rid of all this and go back to 10. Right? Let's go ahead and look at a while loop. Right? While I is less than, say, n, I will go ahead and print out I. Of course, that means that I need an I here. Int I is equal to 0. Why did I need to declare it here and here? Those of you coming from a C background, scoping. How does scoping work? Scoping is where you declare a variable, and that's the existence of the variable. In Python, if you set a variable x is equal to 42, that's now a global variable. Any piece of code can see that variable as long as you're looking for globals. I forget what, in the local scope, if you've got a local variable x, I forget which one takes precedence, and then you have to declare, no, I mean the global variable x, or I mean the local variable x. I forget which one it is, right? But it's something that you do have to deal with in every programming language. Where does this variable exist? For this declaration right here on line 8, I only exists for this for loop. After this for loop is done, I no longer exists, and you can see that it's a compiler error. I have no idea what you're talking about. I does not exist at this point. It existed only for this loop. Generally, you want to scope your variables down as restrictive as possible. You do not like global variables. Globals are evil, right? Anything that's bad or bad practice is called evil in computer science, right? In fact, say what? What makes global variables bad is because now everything can see it, everything can change it, and so now you need to test for the eventuality that everything will change it, right? It makes your program far less predictable. If pi were a global variable, for example, right? What's to stop me from writing code over here in this module that changes pi to 3.14, right? And you were expecting it to be much more precise over there, right? Global constants are okay, right? Because you can't change those. But global variables are not. They also pollute the namespace. Once you name a variable x, guess what? There's one variable named x, period, right? So you want to scope things down as small as possible. In this case, because I've already, I'm going to have to redeclare my I and say, actually, let me go ahead and leave it like that. It still won't compile. Why? There's going to be a different message here. The different message is, and you can't see it because I can't zoom in on it, but the local variable I may not have been initialized. Those of you coming from a C background, if you declare a variable like this, int I, what is the default value of I?
0.
Could be 0 if you cross your fingers and hope, right? Otherwise,
default is 0, but there's always a chance you get dead beef for it.
Dead beef, uninitialized variable, whatever was in the memory space beforehand. In Java, it doesn't even let you do that. Java, you are required to provide an initialized variable before you use it, right? So I'm going to go ahead and start it out at I here. What's my problem though? I started I at 0. It is strictly less than 10. I print it out. And so what's this going to print? 0, 0, 0, 0, 0, 0, 0 forever. First of all, how do I kill an infinite loop program? The stop button down here. If you start it with the play button, you stop it with a stop button, right? If I do this using a debugger here, let me go ahead and get rid of this breakpoint here. Yes, I do want to delete that breakpoint. Actually, I regret doing that now because I could show you that over here there's a checkbox. You can actually disable that breakpoint without having to delete it so that you can come back and without having to recreate it and then re-enable it. But I'm going to go ahead and put this through the debugger. You can see that this is an infinite loop. Where is it infinite looping on me, right? Go ahead and hit the pause button and it'll show you, right? Where am I? Oh, no, I don't have a breakpoint, so where am I? Oh, I can't just continue. All right, fine, continue, stop, pause. Okay, well, it'll tell me where I am on line, well, it'll be line 14 here somewhere. Then you can set a breakpoint, continue, and then see that, oh, okay, now it's obvious. What did I forget to do? I is always going to be 0. My intention was to increment it to 1, 2, 3, 4, 5. Let's go ahead and do that here, I++, okay? I'm going to go ahead and terminate the debugger here and go back to my perspective, my Java perspective, right? Now, what is this going to print? Let me go ahead and get rid of this block of code so that we don't confuse them, right? What is this going to print now? I starts out at 0. I is less than 10, so it goes into the loop. What does it immediately do, though? Adds 1. So what's the first thing that it's going to print? 1. Then 2, 3, 4, 5, 6, 7. Why does it print 10 now? The for loop that was kind of like this only went up to 9. And I'm only strictly less than 10. So yeah.
Because unlike the for loop where it adds after everything is done, the while loop is going to add before it thanks to where you put the code.
Good. So the answer that he just said was that with a for loop, the I++, that occurs always at the end of a loop, right? With a while loop, it's up to you. Do you want to put it the first thing that you do? The last thing that you do? Choose not to do it at all, right? Or if you've got like 5 or 6 different lines of code, you can do it somewhere in the middle, right? So a while loop is a little bit more versatile and it's a little bit more flexible. If you have things that you need to do a little bit different, right, then you need to do a while loop, right? Let me go ahead and restore that. And that now will print 0 through 9, just like the for loop. It's exactly like the for loop here, right? As a preview of what we're going to look at next, here's how do you iterate over, say, an array of elements, right? So int primes is equal to, this is going to be an array, 2, 3, 5, 7, 11, 13, 17, 19. There we go. That's good enough. The first, 8 primes there? So one way that you can do this is using an idiomatic for loop, right? For int I, let's find out what's going to go on here. Primes.length, right? I++. Right? There's my idiomatic for loop. It's not going to let me declare this I here. For the same reason that we just discussed with scoping, right? Once you've declared a variable, that variable now exists for the remainder of the scope. I don't want to drag that, sorry, right? In other words, I exists right here because I declared it outside the loop. I still exists after that while loop. Therefore, you cannot have 2 variables named I. One option would be to get rid of that declaration and just reinitialize it to 1. Another option would be to use a different value, right? J instead. All right. I don't like that. Let's go ahead and redo this one. Here's a trick. Right? Refactor, rename, J. Do you see that magic? Right? J was changed there, and there, right? Because it was able to determine, okay, this variable is declared right there, and it exists there, and there, and there. So if you rename this one, I will automatically rename everything for you, right? Really cool trick. So I'll go ahead and use j there. And now I can use I down here. The second thing I want to draw to your attention is primes.length. What do you think that the length is in this case? What value does it hold, do you think? 8. Why? Because there are 8 things in that array, right? So for those of you coming from a C background, we'll breathe a huge sigh of relief here because you immediately see, no bookkeeping at all. Excellent. Anytime I have an array, to determine the length of that array, the size of that array, all I need to do is dot length. By the way, in Python, what would you have done? In Python, you don't have arrays, you have lists, right? The first element is at index 0, index 1, index 2, ... How do you determine the length of a list in Python? How many people are coming from a Python background? Okay, at least a half a dozen that admit it, right? Come on, so tell me, how did you do the length of an array or a list or a set or a dictionary or anything? L-E-N, right? Foo? There, that's the length of the list. You don't have to do that. You probably don't remember that because the way that you would iterate over a collection in Python would be something like this, for x in primes, right? And then you would do whatever you're going to do with it, right? And so you never really had to worry about the length of a list or a collection or whatever, but it's the same way, right? Length, right? Oops, there we go. All right, so to get the ith element, I'm simply going to use indexing, which is the square brackets. So system.out.println primes sub I. There we go. Does the dot length measure starting at 0? The indexing starts at 0, yes. And so dot length here will run, in fact, let me go ahead and format this a little bit better here. Primes of %d is equal to %d, just to show you what I'm talking about here, I and then prime sub I. Right. Now let's go ahead and run this and I'll show you what I'm talking about here. Prime sub 0, that's going to be the first element, 2. Prime sub 1, 3. Prime sub 2, 5, ... Prime sub 7 is going to be 19, that last guy right there. Right? Why was dot length 8? Well, because you start at 0 and then you count 8 forward. What's the last value? 7. That's why we call these things idiomatic for loops. They're so common that it's just like spitting out a sentence in English. Once you are fluent in a language, you don't even have to think about it, right? Once you're fluent in a programming language, you'll be able to spit these common pieces of code out without even thinking about it. Right? But for those of you coming from a Python background, again, you would do something like this. For x in primes, you would go ahead and print it out. Right? We have something like that in Java. Right? We have what's called an enhanced for loop. For integer, int x, in the collection primes, go ahead and print it out. System.out.println x. Right? And again, this is read, you read this, read as for each integer x in the collection primes, ... Right? And then you print it out. So something very, very Pythonic, right, or Python-oriented, we also have that in Java. Let me go ahead and print and run this and show you that it will print 2, 3, 5, 7, all the way up to 19. If you do not need the index variable I, then this is the preferred way of doing it. And again, that is a colon, not a semicolon. For each integer x in the collection primes. Right? It's almost virtually the same as the for loop in Python. Another question online? Arrays with one element and it's indexed at 0, but the length is always going to be 1. Yeah, you might end up having an array of size 0, but those are kind of useless, so I'm not even going to show it to you. Right? Okay. So there are the basic loops in Java. Right? Any questions on that so far? Java. Oops. There we go. There. That's all in your notes now. And again, as I posted on Piazza for the week 1 retrospective, I posted the link directly. Those are going to be pushed out on a daily basis or at the very least on a weekly basis. Yeah? Okay, so undo. Let's go ahead and go back, because you need some code to actually set a breakpoint. But this over here, so you can see over here that there's this minus sign, and that allows you to collapse a code block, right? And then within that, you can, there's this little blue line over here, and anywhere over there, you can go ahead and double click. All right, double click. It's not a single click, it's a double click. Sometimes you can't click on them because, for example, line 10, that's not an executable line. So I can't double click as many times as I want. There's not going to be a breakpoint there. But double click, and before that, double click. Yeah, there. So 3 breakpoints there if you really want them. I don't want those. Let's go ahead and get rid of those. There. Save it. Is good? All right. Okay. So again, this thing was called an array. Java has arrays. So arrays and collections. I'm going to show you arrays really quickly, really briefly, because we're going to immediately abandon them, right? So an array is simply just a collection of a fixed size of a fixed type. If you want an integer array, you can do what I just did and immediately set its value. You don't have to declare its size. But if you want an array of, say, 100 integers, right? So let's go ahead and create an array of 100 integers. Those coming from a C background, how would I end up doing this? I would have to call malloc. I would have to call malloc to set up memory, typecast that memory, and then when I'm done using it, I need to make sure that I free it up. We don't have any of that in Java. We have a garbage collection. I do have to create it, though. So let's go ahead and create an integer array, right, of numbers. Right? You know that it's an array because of those square brackets. This is one single array, integer. This is a collection of integers. Now we're going to use something called the new keyword, int of n. Oops, sorry, n. There we go. That's like calling malloc for those from a C background. For those from a Java background, you never had to worry about this at all, because if you want to extend the size of an array of a list, you just did it. You append something at the end, or you insert something at the beginning, or you do whatever you want to do with it, and it'll automatically and magically increase its size for you. In Java, a plain old integer array does not do that. This is going to be of size 100, and I don't have enough fingers to hold up, but it's going to be of size 100, and will only ever be of size 100. Right? You cannot shrink it, you cannot grow it. Right? If you do things like, say, let's go ahead and set the first value to 42. Array of 0 is equal to 42. We have 0 indexing in all 3 languages that we're talking about here. And so therefore the last element, set the last element to, I don't know, 101. Array of, what's my last element? Where is that going to be? 99. What's a better way of writing that? What if I went up here and said, okay, now it's only of size 10? Right. Yeah, don't do that. And minus 1, or even better, what's an even more robust way of doing this? Array.length, right? The size of the array. And I'll set that equal to 101. Actually, is that correct?
No, you have to
Minus 1. Why? Because you start at 0, you're always going to be 1 less on the other side. Okay. All right, so what if I do something like this? Array of -1 is equal to 3. What if I do array sub 100 is equal to 4? The compiler doesn't care. The compiler was not able to determine that how big it is. If you were to do something like this in Python, and by the way, in Python you have square bracket notation, so this should be 100% familiar to you. In Python, is this okay or bad? Oh no? Yeah, it's okay. Why? Because negative values wrap around to the end of the array. Or wrap around back to the, yeah, negative values would wrap around back to the beginning. You could put in negative 1 million, and it'll wrap around as many times as it needs to, and then end up going backwards somewhere. What happens in Java? Exception. Index -1 out of bounds for length 100. Likewise, it'll occur, sorry, there we go. It'll occur on this other one. That's also going to be out of bounds. Index 100 is out of bounds for length 100. We don't have that feature in Java. What would happen in C?
Memory error.
Memory error, bus error, segmentation fault. It could just, okay, you're just corrupting your own memory. Great. It's your memory. You do with it what you want to do with it, right? It might not even manifest itself as an error, right? But it's definitely undefined behavior. So these are index out of bounds exceptions. And we'll talk about exceptions later on here. That's something new for those folks coming from C, all right? All right, so that's how you use arrays. Now we're immediately going to stop using them, right? Because, again, we are in a language now that we can afford better, right? So basic arrays are supported, but you should not use them, right? Unless you have to, right? And I'll put that in the notes so that you have it, but again, we can afford better. We can do better. Now, those of you coming from a Python background, you'll immediately say, okay, good. I see this and I know what I'm doing now. A list, right? What other collections do you have in Python, by the way? Lists, they're ordered. What else? Dictionaries, good. And tuples, okay, wow, good. And what else? Sets. We're going to look at lists, sets, and maps, which are basically better dictionaries, right? So this is going to be a list of integers. First of all, a question. Array index out of bounds exceptions. Yep. Okay. A list of integers, and I don't know, I'll call it numbers, right? Is equal to new array list. Don't worry about what an array list is until much later, and do worry about the correct spelling of integer, though. Right? There we go. And then we're going to have to bring these in. These are all defined in the collections library, java.util. Right? A list is an interface, an array list is an implementation of that interface. Don't worry about it. Just understand what the syntax is doing. This is a list of what? And then this, we call these Langle-Wrangle, right? Yes, it is less than, it is greater than, but when it's in this context of a delimiter, we call them Langle-Wrangle. Why? Left angle bracket, right angle bracket, right? Langle-Wrangle. And it's going to be a list of integers. That list is going to be called numbers, right? And then I'm going to create a new array list implementation of this. I repeat, this is not diamond notation, but I repeat the Langle-Wrangle. Old school Java, you would have to repeat the type, integer. New school Java, it's smart enough to figure out, well, I can look at the left-hand side and see what you mean, right? So you don't have to retype that. And then what this is doing is it's calling a constructor here, okay? Once I've got that list, I can do whatever I want with it. I can put stuff in, I can take stuff out. This is called CRUD, create, retrieve, update, and destroy. I can put stuff in, I can retrieve stuff, I can update stuff, take that out and replace it. I can delete stuff. How? Numbers.add, 10. Numbers.add. I don't want to go in order here, so 5. Numbers.add 20. Right? Now, those of you coming from a Python background, if you've got a list, how do you add stuff to the end of the list? Append. That's what this is doing. Right? Let me go ahead and print this out. System.out.println numbers. What's going to be in my list? It's ordered, right? And everything is contiguous. So it's going to be 10, 5, and 20, because add always adds to the end of it, right? If I want to add 42, it automatically gets added to the end. Right? If I want to add another 42, what's going to happen? Let me go ahead and print it out. 2 42s. Why? Because it's a list. It's not unique. Sets are unique. We'll talk about those after this, right? So I can put stuff in, right? What if I want to add something arbitrarily? Numbers.insert. Isn't it insert.in? Oh, no, it's also .add. It's just a 2-argument add. There we go. I want to add something to index 0. Let's go ahead and add 101. What's that going to look like now? If I add something to index 0, where is it going to end up? At the beginning. For Python, what was the shorthand for inserting something at the beginning? No, it's also insert, isn't it? It's insert. Okay, I forget what the function is, but there it is, 101. Insert, and then you define the index and the thing that you want to add to it, right? All right, great. Well, what if you want to insert? My thing is lag, dot add is Java, yep, exactly. Dot add is Java's version of append, right? Let's go ahead and append something else, -4, to right in the middle, 3, right? So let's predict where that's going to be first. At index 3, where is that? That's index 1, 2, 3, or sorry, 0, 1, 2, 3. It's going to insert it right there. What's going to happen to 20, 42, and 42? It's just going to be shifted down automatically. There are no gaps. It takes care of all those details for us. Let's go ahead and see that it's going to be 101, 10, 5, -4, and the rest. Right? Perfect. I don't have to have any of those headaches anymore for the C folks, right? Once you see lists and dynamic data structures, you will never use another plain old array again, right? Once you see maps and dictionaries, you'll never use lists again. And we'll look at that here in a second, right? All right, that's adding stuff. You can remove stuff, right? So for example, numbers.remove. Let's go ahead and remove that -4 that we just put in. And it's going to go through and find the variable that we're, I hope, nope, sorry, that's going to be index-based. So let's remove, I don't know, 10 at index 1, right? And then print it out. Remember, 10 is at index 1 here, so it'll end up being 101, 5, 4, -4, ... or the rest of them. If you take something out, it automatically shifts stuff down so that it has no gaps, right? If you want to remove everything, numbers.clear, that'll remove everything. If you want to .remove, isn't there remove? Nope. .pop? Nope. I forget what it is. Yeah, let's go ahead and remove something at some index that clearly does not exist. What's going to happen here? Does the element at index 100, the 101st element, does that exist? Nope. So likewise, index out of bounds exception here. Right? Anytime that you are going to be working with a list or just like an array, you still have the valid bounds. Yeah, you can go ahead and add stuff all you want. You can take stuff out and it'll automatically shrink and grow as automatically for you. But if you work outside the bounds of what's in there already, then it's going to be an exception just like an array. Question online? Add method adds new stuff at the end of the list. Exactly. Yep. Oh, so you're cross-talking and answering each other's questions for me. Thank you. Right. I'll still monitor it though. So you can put stuff in. You can take stuff out. That's the create and destroy or update. What about retrieving stuff? Right. So for int I equals 0, I is less than, say, numbers.size. There is no .length property. Right. This is a little bit different because it's a list. .size is an actual method that you call, and it returns however big that array, that list is. In this case, how big is it? Now that we've, let me get rid of this so that it actually runs. How big is it before that happens? 1, 2, 3, 4, 5, 6 elements in there. It'll return 6, and so we'll run from 0, 1, 2, 3, 4, 5, but not including 6, because we're only going to go up to, but not including that last one. System.out. .println x. So how do we get that thing? Int x is equal to numbers dot, well, how do you get something out of the list? Get sub I, right? It is a method. Give me the index at which you, of the element that you want, and I'll give you that element back. And let's go ahead and print these out. 101, 5, -4, 20, 42, 42. Exactly what we would be printed if we just printed it immediately to the standard output. Right? As an alternative, remember that enhanced for loop? Did I actually use the index here other than to get the element? No. I can go ahead and write a much quicker loop for int x in the collection numbers system.out.println x. X is automatically updated. It'll iterate through that list from the first element all the way to the end of the element and then jump out of that loop. So there it is the first time, there it is the second time. Nice. Right? 101 through 42, the second copy of it. Right? It'll go in order. Those are lists. So if you're coming from a Python background, you're going to be very, very comfortable using this stuff. It's just that you're going to have to look at the documentation for the various functions. Instead of append, we have add. Instead of insert, we have add that takes 2 arguments. Instead of a for loop that you iterate over the collection, you use an enhanced for loop instead. Okay? So, those of you coming from a Python background, tell me what a set is. Or those coming from a math background, what is a set in math? It's a collection of stuff, right? But it is unordered, right? So sets are unordered. Unlike a list, there is no first element, there is no second element, there is no last element. There are just elements, period, right? Sets are unordered collections of, and then what's the other thing? Unique elements. So if you've got a set in Python and you want to add 10, 20, and 30, what happens when you add 10 again for the second time? Does it have any effect? Nope. No duplicates, right? That's what uniqueness means. There are no duplicate elements, right? Yep, collection of unique elements. There's always going to be a 10-second delay, folks. Sorry, that's just YouTube, right? So a set of integers here. And I'll go ahead and go with numbers again. Numbers is equal to new hash set. If you know what hashing is, great. If not, don't worry about it. A hash is a function. It's a hash table implementation, basically. And let me go ahead and import all this stuff. There we go. All right. So I can use the exact same interface as before. Numbers.add 10. Numbers.add 20. Numbers.add 30. All right. Let's print that out. System.out.println numbers. There we go. And let's go ahead and add 30 again. Remember, unique elements. It's going to have no effect. Another observation. I added 10, 20, 30. Did it add them to the end of the set? No, because sets are unordered, right? There is no ordering. 20, 10, 30, that's just the order that it happened to store it in the hash table that was living under the hood, right? Don't read anything into that ordering, right? If you change the collection and then iterate over it again and print it out, you could get a completely different ordering because it is unordered, right? So here's a good question. How do we get stuff out, right? Create, retrieve, update, and destroy, basic CRUD. How do I remove something or how do I retrieve something at least? Numbers.get, right? Will this trick work? I want the second element, the element at index 1. No, because there is no indexing. There is no first element. There is no second element. Right? So what am I going to do? An idiomatic for loop for int I equals 0? Nope. I'm not going to be able to index it at all. Instead, I need to use that enhanced for loop. Int x in the collection numbers. Oops, sorry. System.out.println x. I'm not using an index with the enhanced for loop here, and consequently, I'm going to get the same ordering as the print function, or just printed it out, but that's how you iterate over it. Right? How do you remove an element? Let's go ahead and add 40. You'll see that there now is 40 in there, but then let's go ahead and immediately remove it. Numbers.remove 40. Now, because it's not index-based, this is not the index 40, this is the element 40, and you'll see that it ends up getting removed. Right? 40 is in there, we remove it, and consequently it's not there, and it's not there when we print it out down here. Right? Here's something that you might eventually see, x.add, or not x.add, but numbers.add 42. Let me cross my fingers and hopefully what I'm intending to do here is for it to error out. We'll find out here. Yep. Concurrent modification exception. So you're walking on a rug. Say that there's a red rug going all the way out, right? Can you pull that rug up while you're walking on it? You can, but what's going to happen to you? You're going to trip and fall. So while you're iterating over a collection, the rug, right? While you're going to the first element, the second element, the third element, the fourth element, can you pull that rug up while you're doing that? No. Concurrently, you cannot change it while you're iterating over it, right? There are ways that you can get around this if you want to, but not like this, not with the plain old collections. If I'm going to add, okay, here I'm going to print out the first one, the second one. Remember, there is no first or second. It's just the idea of it. The first one, the second one, I'm going to go ahead and add one back there. Uh-oh, right? I skipped it, right? So that's why it doesn't allow you to do something like this, right? You'll have to think of a better way of doing something like that. So let me go ahead and get rid of this error, right? And concurrent modification. You cannot, at the same time, simultaneously, iterate over a collection and modify it. You need to do one or the other, okay? Otherwise, you need to find a better way of doing it. There's sets, and we'll only have time to preview it here, but those of you coming from a Python background, if I asked you to do something and you had a choice between a list or a set or a dictionary, which one would you choose? Dictionary, why? More better, exactly. It's definitely it's definitely better. Why? Because it allows an arbitrary, not an arbitrary, but a key value mapping. Here's my map, right? I'm going to map integers to strings, right? Because I want to map, like, say, an NUID to a name, right? So NUID to name, right, is equal to new hash map, right? And what I can do is I can go NUID to name, and I'm going to put into there my NUID 351400602 and my first name. There we go. I am mapping a number to a string, right? That's exactly what a list does. That's exactly what an array does, except that you are constrained. You can only use integers, and you can only use integers 0 up to the size of the array minus 1, or the size of the list minus 1. This, I can use arbitrary numbers. I can use arbitrary objects, in fact. 1, 2, 3, 4, 5, 6, Alice, and Bob. Right. Let me go ahead and print this out, and then we'll end it here. .println NUID to name. Right. There we go. And you'll see syntax. Come on. Save. Oh, I need to import it. Sorry. Import. There. You'll see syntax that looks very, very similar to a dictionary. Curly brackets, and then you have a key mapping to a value, right? That's what a map is. But in Java, a map is much more versatile because you can use arbitrary values for string or for keys and an arbitrary value for values. All right. Wednesday.